All right, ITS148. Today is January 24th, and we're starting chapter 5, I think. And so I'm going to switch over to my screen. And it's this class. And so today, if we look at our overview, we are in starting chapter 5. So I'm going to start lecturing chapter 5. This weekend I'm going to grade everything that's handed in. You can still hand stuff in afterwards, of course. So I can see where everybody is and start focusing that way. I gotta start doing more of that. Kind of neglected a little bit of that last semester, but in 148 I need to do that because this is the last time I see a lot of you, and I want you to leave with a certain amount of basic knowledge, and do my best to get you there, to get everybody there. And so if I'm going to download the slides. We're on chapter 5. I'm going to save it to my special place here, and open it up. Code structures. Okay, now in one chapter we're going to learn about, if, then, else, while loops, do loops, switch statements. They're called switch statements in C#, and stuff you already know already, but we're going to go over it one more time for those of you that haven't coded for a while. So we're going to, given a Boolean expression for the values, given a Boolean expression and the values for the variables, evaluate the expression. Okay, so we're going to learn how to evaluate, we're going to review how to evaluate expressions. Expressions that give a true or false result. So there's going to be some comparison in there, or some testing for equality, or something. There can be calculations like multiplication, division, everything, but the last operation that's done is something where you're comparing or doing something, and so the result is going to be true or false. And we use if statements as needed. If and switch statements, very similar, but they sometimes it's better to use a switch statement. Sometimes it's better to use an if statement, and the underlying implementation is a little bit different, but you don't need to know that. And then how to use while, do while, and for loops. And you recall that we had an assignment last semester where we kind of, replaced one with the other. And so we'll just review that. We're gonna, for the knowledge objectives, we're gonna compare if, then, else, and switch, differences between the loops, explain break and continue. Well, I don't think we covered break and continue, but turns out that you can, if there's a break, it's a facility where if you're doing a loop and you decide right in the middle of the loop that you're done, you can just, you put in a break statement and it pops out to the end of the loop. It's not necessary in programming languages. It's not necessary, but there are often, programming languages often offer you multiple ways of doing things. Actually, all you need is a while. It turns out that all you need is a subtract and some sort of, well, anyway, that's theoretical. And then we're going to describe the use of breakpoints, and that's for debugging. So we may want to stick something in our code that stops at a particular point, and we get to look at all the variables. Programming is all about, doing stuff that you have these variables, which are, memory locations in the RAM, and your program reads memory locations, does calculations, writes back to other memory locations, loops around, continually reading memory locations and writing back to memory locations. Every now and then we'll take the contents of a memory location, convert it into a text string and display it out on the screen. And so debugging, if you're debugging a big, long, complicated program, you may think something is going on in the middle of a loop, but you want to check and look at it to make sure. So you can insert a breakpoint, and that'll it'll let you stop and look, and then you can start back up again. And block scope and context of control structures, that has to do with where variables. When you declare variables, it's the scope of the variables. In other words, you declare a variable and you store stuff in the variable, and where is it legal or valid to actually store stuff into that variable and to take stuff out of that variable. That has to do with the scope of the declaration of the variable, and that is where it is defined will define the scope. It's not that complicated. It's just complicated to express. So these are the relational operators. Am I sharing my screen? Yes, I am. Am I recording? Yes, I am. Okay, so we have these relational operators, and what it is, for equality, for example, you got something on the left and you've got something on the right, and you're testing to see if those two things on the left and the right are equal. If they are equal, the entire expression evaluates to true. If they're not equal, the entire expression evaluates to false. Inequality is just the opposite. If they are equal, it evaluates to false. If they're not equal, it evaluates to true. Greater than is simply if the expression on the left is greater than the expression on the right, it evaluates to true. Otherwise, it evaluates to false. Less than is less than is if it's less than on the left than on the right, then it's true. Otherwise, it's false. Greater than or equal to is if it's greater than if the left side is greater than or equal to, then it's true. If it's less than it's false. And then there's less than or equal to. It actually turns out that if you've got something like, can I write something here? Just let me write. Turns out if you have A is less than or greater than or equal to B, that is the same as B less than A. Turns out. And so there's this inverse operation for all of them. We have if we have same with the other one, if A is less than or equal to B, it's the same as B is greater than A. And also we have if it doesn't quite work with equality and inequality, but we can say A is equal to B is the same as not. We haven't gotten that far yet, but it turns out it's not. A is not equal to B. So there are these inequality things too. This is the same as not. A is less than B. So there's all these inverse things too. So again, you only need some of them, but we have the rest of them just to make it easier to write code. So here's some examples of how these relational operators work. If this first name variable, it would be a string variable. If this string variable is equal to, quote, Frank, end quote, then this whole thing equals true. Same with this one, as you're looking at the text property of a text box. The name of the text box is txt years. and it's basically looking to see if that text box is empty, or more specifically, if the text property of that text box is empty. Here, message equals null. Null is different than 0. Null is different than empty string. Null is a variable that's been declared, but you haven't written anything into it yet, I think, in this language. This tests to see if the discount percent is equal to 2.3. Tests if invalid is false. So invalid is going to have to be a Boolean variable. And so Boolean variables can only take on a true or a false. Here, whatever type code is, product code has to be a compatible type. It doesn't have to be the same type, but it's got to be a type that you can test equality with. And then this tests if the string variable last name is not equal to Jones. This tests if the integer value of years is greater than 0. This tests to see if whatever I is less than months. This is for what's this word value here for? I don't think this word value should be there. Makes sense. So anyway, and then we have these logical operators, and these logical operators work on expressions that are they're called we've been talking about Boolean expressions. So for example, all of these, when they're evaluated, it's going to be true or false. These are expressions, and when you evaluate these expressions, like a plus b is an expression, and when you evaluate it, you get some number that's equal to a plus b. It's some number, unless a and b are strings. A plus b would be another string, a concatenated with b. These expressions, even though the operands are not Boolean, they could be, but even though they're not, when you evaluate the expression, the result of that evaluation is either true or false. Well, you can have Boolean expressions, and then you want to say if both of these Boolean expressions are true, then you do this. That would be this ampersand. So there's going to be something that's a Boolean expression on the left and something that's a Boolean expression on the right. It could be things like this. These are Boolean expressions. If both of them are true, then the whole result after it's evaluated is going to be either true or false. And if they're both true, it's going to be true. For OR, as you know, OR is only one or the other has to be true. They both don't have to be true. The only time an OR expression is false is if they're both false. They both have to be false before the whole thing is false. And then this ampersand is just like a single ampersand with and the or is like a single or. The only difference between a double ampersand and a single ampersand, the way a double ampersand works is first it evaluates the first expression, and then since it's an and, it's smart enough to know that, well, if the first expression is false, then we don't even have to evaluate the second expression because we already know the whole thing is going to be false, because false ANDed with anything is false, because for it to be true, they both have to be true. So with ampersand, only the first one needs to be evaluated. With double or, just two vertical bars, It's only the first one has to be evaluated sometimes. If with ampersand, if the first expression, if the expression on the left ends up being true, then you have to evaluate the second expression because it depends on the second expression. If the first expression is false, then you have to evaluate the second expression because it's going to depend on the second expression. If the second expression is true, it's going to be true. If the second expression is false, it's going to be false because the first expression is false. With a single ampersand, they're both evaluated anyway. So it evaluates both of them, and then it figures out the result. Or it'll still know the result after the first one, but it still evaluates the second one anyway. Now, why would you do that? Well, if you have something like, if the second expression is something like plus plus, if you have if I is equal to j, if you have something like, let me see if I can do this. If you have if I equals j, it's capitalizing it for me. Ampersand k equals m, and you do something like this, plus plus, or let's say you do something like j plus plus, then you then do something. What this will do is it'll evaluate. It'll take I, and let's say I is 5. And let's say I is 5 and j is 5. It'll do it is 5 equal to 5, but then after it does that evaluation, it's going to add 1 to j. So right after this thing is evaluated, j will be 6. J will be added. You add 1 to j. Here it's the same. Here would be the same thing. If let's say k is 10 and m is 9, it says, is 10 equal to 9? No. Then right after that, there's a plus plus, which makes m 10. You follow me on that? So let's say in your code, whatever happens, you need to have m incremented. No matter what happens, you still need m to be incremented. Well, in that case, you would have to put a single ampersand because you want them both to be evaluated. You're still doing a Boolean expression where they both have to be equal, but you want that second one to be evaluated because you need the plus plus thing to happen. And sometimes you don't want the second thing to happen. Okay, why wouldn't you want the second thing to happen? Well, it could be that let's say it's doing and if it's and then if I is equal to j ends up false. Let's say if I is not equal to j, then this is going to bomb. This is going to cause the thing to bomb. It's only if I is equal to j that this thing won't bomb for some reason. And later on, we might come up with an example of that, and I'll point it out. But so sometimes you actually want to take advantage of that. And an example would be like if you're reading something out of the file or something, and the file's already empty or something. And so this thing, if this thing is false, then the file is going to be empty. So then you don't want, and let's say this thing reads the file. You don't want to read an empty file because the thing will blow up. So anyway, there are some examples. It might not be obvious to you right off the bat, but there's some examples where you want to use this double ampersand, and there's other examples where you definitely want to use a double ampersand, and there's other cases where you definitely want to use just a single ampersand. This not thing, this is like a not, the opposite. this actually, you know, reverses the value of the expression. That's kind of what I was using here. This thing, this thing does something, and whatever this is, it's going to be true or false. But when you put this in front of it, it makes it the opposite. If it was true, it makes it false. Well, not false, it's made true. And so here, this one, if the subtotal is 200, let's say the subtotal is 200, then this expression, the second expression, will never be even evaluated. So you could have something like, I'm just gonna throw this out there. I'm gonna say subtotal. If the subtotal is not equal to 0, it's true. Yeah, let's say the subtotal. I'm just gonna make this up here. Oops. Let's say you got that, but really what you have instead is if subtotal equals 0, sub is not equal to 0. And subtotal divided by and 100 divided by subtotal is great. Let's say you have something like this for whatever reason. So if subtotal is not equal to 0 and 100 divided by subtotal is less than 500, you know, let's say you have an expression like that. Well, you need the double ampersand. Why? Because what happens if subtotal is equal to 0? I mean, what happens if this is false? Well, if that's false, then you know that this whole expression is going to be false, because anything false and something else is going to be false. So you want this thing to just evaluate that, and if that's false, then you don't want it to go any further. Why? Because if this is false, then that means subtotal is equal to 0, right? If subtotal is equal to 0, then this is going to bomb, because you can't divide anything by 0. It's against the math rules. It ends up being infinity. So so this is an example where I didn't mean to do that. Where in this case, you know, you want to use a double ampersand, because if you use a single ampersand, whenever subtotal is equal to 0, then it's going to bomb. So anyway, here's an example of what I was saying before. You test. Oh, let's do this one here. If time in service is less than 4 or time in service is greater than 12. Okay, so that means the only time that this expression is false is when time in service is equal to 5, 6, 7, 8, 9, 10, or 11. Because if it's 5, 6, 7, 8 timer, 5, 6, 7, 8, 9, 10, or 11, then this is going to be, first one's going to be false, and the second one will be false. So then the whole thing will be false. These invalid examples here, these are examples of when you would want to use a single one, because in this case, for example, you would want the counter to be incremented by 1 no matter what. You want the counter to be incremented by 1 no matter what. And this one, this thing, let's see if I can get this to bigger. In this one, we evaluate this, and if this is true, well, no. Okay, first we evaluate this. Well, let's see. If we evaluate, there's an ampersand this, and then there's an or. These are two different expressions. These are two different expressions. This doesn't need to. This should really look like that. So this thing, okay, now here we're getting into operator precedence. Operator precedence. So just like if you have an expression that's got addition and multiplication, no matter which operand, no matter if the addition occurs first or the addition occurs second, or no matter if the multiplication occurs first or the multiplication occurs second, you always do the multiplication first, because operator precedence in math means that you do multiplications and divisions before you do additions and subtractions. If you have a multiplication and division in the same thing, it's left to right. There's no precedence, so it's just left to right. But if you have multiplication and addition in the same expression, you do the multiplication first, and then you do the addition. If you want it to be the other way around, you got to use parentheses. So in this case, and anding has operator precedence over oring. So you can think of anding, and in a lot of languages, the and operator is the multiplication operator, and in a lot of languages, the or operator is actually a plus sign, and it follows the operator precedence thing as the same thing. You have a multiplication is first, and if you think of binary numbers, you know, anding, I mean, 0 times 1 is 0, and false and true is false. So it ends up kind of making sense when you think about it a little bit. Okay, so in this case here, it's going to do this one first to figure out if that's true or false, and then it'll do, and then if this whole thing, okay, so look at this. If this whole thing ends up being true, then this thing does not have to be evaluated. Here, the ampersand is there, but we're going to do this thing first. Why is there another parentheses? Why is there another parentheses here? This doesn't make sense. It shouldn't have another parentheses here. What whole thing?
Yeah, that doesn't make sense.
Doesn't make sense. So let's just get rid of this parentheses right here. So it's going to do this thing first, and then it'll do this one here.
Oh wait, no, that was right first.
It was?
Yeah.
Why? Why? Where's the closing parentheses for that?
Right at the end of part time.
Oh yeah, it is. Yeah, this is the closing parentheses of this, and this is the closing parentheses for this. Right. Good. Thank you. So, oh yeah. I don't know. Why do we need parentheses? Why do we need this? Why do we need the parentheses around here then? Why do we need this in parentheses? Who knows? It doesn't matter. You can always throw parentheses in if you want to. And with this one, first we evaluate the inside. Is counter greater than or equal to years? As soon as that's evaluated, we add 1 to the counter. But if counter is greater than years, and then we do this not. So we could do this if we wanted to do the same thing. The other thing is that this is obviously a Boolean expression, or it evaluates to a Boolean value, or it's a Boolean variable. It's just true or false. Well, so it's like this is true or false if it's equal to true. I mean, so you don't even need this. You actually don't even need that, because this is already true or false. But usually for readability or whatever, you put that in there if you want to. lot of different ways you can do these things. Okay, so the syntax of an if-else statement, I may mistakenly call it if-then-else because in lots of other languages you would put a then, you'd put the word then right here. Do this. In a lot of other programming languages, you would put the word then right there, and then you'd have the word else here, but not in C#. So it's just called if else. Wouldn't make sense to call it if then else. So if Boolean expression, and the Boolean expression can be any of these ones we've had before. It can be big, long, complicated thing, as long as at the very end we end up with a true or a false. And then these are the statements that we want to execute if this evaluates to true. If it doesn't evaluate to true, then it skips it. It either skips it altogether, or if there's an else clause, then it'll do the else clause. Now, the reason that there are square brackets here, that means it's optional. It means it's valid. The syntax is valid whether or not you have an else there. And you notice that you can have else if. You can have else if, else if, else if. You can have as many else ifs as you want. And then at the very end, you can actually just have a plain old else, which sort of catches everything else. Everything else. And so these square brackets means it's optional. And by the way, Visual Studio is what does these syntax checks. And it does these syntax checks on the fly, which is why when you're typing in Visual Studio, when you type in C# code, you type in some C# code, and then it thinks for a while, then boom, there's a red squiggly underneath something. It's actually doing the syntax check. It's actually making sure that the format of your if statement follows this. And in fact, the programmers who write the code that decides whether to put those red squiggly lines underneath your code, that's called a parser. The most common kind of parser is called a recursive descent parser, and the data for the parser to know what to do is actually code that looks just like this. I mean, it's an expression like this. This is called Backus-Naur form, and the parser actually, looks at this and decides what the syntax of your C# program should be. Anyway, that's just a side thing. Okay, so if statements without if, else, or without if or else. Okay, so so you don't need. So you can just have statements that look like this, and this here is if you're only going to have this. Okay, in other words, if you're not going to have any of this, not going to have any of that, and instead of statements, you're only just going to have one, then you don't even need to put the squigglies. So in other words, you can have something that looks like this. And so this is the same as if you put squigglies here. But since it's only one, then you don't even need to put the squigglies. I meant the squigglies now. Curly braces. I meant curly braces. Curly braces. These are curly braces. All right. So here, for example, we have this if. We have the if part. And then we have two statements that we want to execute should this be true. And so since we have two statements that we want to execute, and only if this is true do we want it to execute, then we use the curly braces. I wonder how many times I said squiggly when I meant curly braces. And the reason that there's red squigglies underneath here has to do with the fact that if this is English, there's no word discount percent all one word. And the same idea is going on here. The PowerPoint has got a parser inside, and it's going along, and it recognizes something that's not English, and it puts a red line underneath. All right. Next is here's an if statement with an else clause, and it turns out again, if you are only putting one statement, you can do this. You don't need to put the curly braces around them. And in the first language, the first language that really made use of the first language that really made use of using curly braces to enclose statements. Well, there's Algol and Pascal, but the way we learned it was if you put curly braces around a bunch of statements, it made it like one statement. So if you have a bunch of statements and you want them to be executed all as a single block, all at once, no interruptions, you put the curly braces around it, and then that's like one statement. So that's the logic behind, in this case, since it's just one statement, that's what goes there. And if you want to have a bunch of them that like mean one statement, then you put the curly braces around it. Otherwise you don't need to. So that's what this is. So after each of these conditionals, you only are going to do one statement. Then you do not need to put the curly braces around that one statement. You can nest if statements, of course. This is a curly brace. This is a curly brace around this thing, makes this one statement. Now you're probably thinking, well, this is just one statement. Why do I need the curly braces? Well, because it may get confused whether this else refers to this if or this else refers to this if. So you need to put the curly braces around it. Instead of instead of if, else if, else if, else if, else, another way of doing something similar is a switch statement, in which case you put the word case switch, and there's an expression here. It's going to be this expression evaluates to something. It's going to evaluate to something here, the constant expression. And so it's going to evaluate to something, and it could be a string, or it could be a number, or whatever, but the numbers that can be are put here in these different case blocks. And then at the end, you can have a default, which means if it's not covered up above, then you do the default. Okay, you don't have to put the default. If there's no default and it's not covered up here, then it's not going to do anything. Now, the other thing about a switch statement is when you find a case that is true. So in other words, if this switch expression evaluates to 1, 2, 3, 4, 5, and let's say this first one is 1. If it's 1, you evaluate these expressions, these statements, and then this break is what makes it come back out to here again. It's this break that makes it not continue down and execute more of these things. Okay, so you really want to get into the habit of putting a break just before the next case, unless you know what you're doing. There could be some cases where you do want to keep on going. It could be some cases where the statements in here, well, these constant expressions here might not be, as they say, mutually exclusive, and there could be several constant expressions that I can't think of an example offhand, but anyway, yeah. So you want to have the break statement in there to stop it. Otherwise, it just continues executing down. So here's an example of a switch statement, and so we have this customer type, and it's going to be it's going to be I guess it's going to be a character or a double. It's going to be a string, and because double quotes. And so if customer type is an R, then it executes this thing. If customer type is a C, it executes this thing. Otherwise, it executes this thing. And each time the break brings it down to execute, continue down here. And here's one that doesn't use the break. So if it's R, then it's going to continue on through, and it's actually going to execute the cases where it starts, and then it continues on ignoring cases until it hits a break. So if customer type is R or C, it's going to set the discount percent equal to 0.2, but the break takes it out. So the case is like a starting point. So here, if you didn't have the break, it would execute discount percent equals 0.1, and then it would just fall through if you didn't have the break here. It's just going to fall through, and then then right away it's going to set discount percent equal to 0.2, and that's probably not what you want, because otherwise, why would you have the first one here? Are we okay? Enhanced invoice total form. Okay, so in this case, we're going to take our invoice form, and we're going to add another text box up above, and we're going to look at that customer type, and based on the customer type, it looks like we're going to set the discount percent. So everything else is the same. You're working on this for the second assignment. You're messing with this, and so we're going to add another thing in there that looks at the customer type, and it's going to assign the discount percent based on the customer type. So this is how we might do that. And so somebody clicks on the calculate button, grabs out the customer type from the customer type text box. So clearly this text box is named TXT customer type, namely this thing, TXT customer type. And this grabs out the text property, which is what is inside this text box here, grabs that out, sets it equal to this string variable called customer type appropriately. And then this takes the subtotal, grabs the subtotal out of the text box. So it grabs this 150 and converts it to an actual, converts it to a 150 that the computer understands, which is going to be, 110110001 or something like that, and signs that value into subtotal. And then it sets the base, it sets the default discount percent equal to 0%. And then looks if the customer type is equal to R, it's going to compute the discount percent according to this if-else statement. Or if the customer type is equal to C, it's going to calculate the discount percent according to this if-else statement. So if the customer type, if the subtotal is 200, if the subtotal is 200 and it's a customer and the customer is an R type, then the discount is 10%, because this one here. However, if you're a C type, then the discount is going to be 20%. So I wonder how you become a C type customer, get more money off. And this is else what? It's an else that, so that's weird. Otherwise, the discount percent is 40%. So if you're neither, it's 40% no matter what. Huh. Seems weird. And then we go ahead and we do some more calculations stored into this internal variable here called discount amount. You don't see anything happening on the screen when this is executed. Then it does this statement here, which takes the subtotal and subtracts the discount amount, stores it in this internal variable called invoice total. You still don't see anything happening on the screen. And then this statement here is executed, and it takes the discount percent, which is this thing, converts it into a string that a human can read, and it formats it like a percent. It makes, say it's this one. It makes it 40 instead of 0.4 because it's percent. It makes it 40%. Instead of 0.4, it makes it 40%. And then the 1 means it's going to be 1 decimal point. So in this case, it's going to be, if it's, let's say it's discount percent of 40, it's going to be, whatever, 40.0%. Because it's P, which multiplies the thing by 10 and puts a percent thing. And the 1 means you want 1 digit to the right of the decimal point. And this is going to take the discount amount and turn it into currency format, which means it's going to throw a $sign in front of it. It's going to put 2 decimal points. It's going to put some commas in there if it's a bigger than 1,000 kind of thing. Same with invoice total. Now these statements here, of course, you do see something happening on the screen. You aren't doing any calculations with this other than taking something that's internally represented as 0.4 and converting it into the characters, converts it into 5 characters. It takes this, converts it into 5 characters, converts it into a 4, plus, and then a 0, and then a point, and then a 0, and then a percent. Currency and currency. And then this, of course, makes the cursor go back to the customer type, which is this thing. It's going to put the cursor back there, or there, ready to type in a different customer type. All right. Let's see, 17:30. Where's a good time? Where's a good place to quit? 4. Okay, I'm gonna go to 20. Okay, we remember we remember do while loops. Where's the do loop? Oh, while loop. Here's the while loop. It's just like an if. It's just like an if statement, except for it comes back and evaluates the expression again. So the syntax is like an if statement also. Instead of the word while, if statement is the word if, while statement is the word while. With an if statement, it's just evaluated. It's evaluated once. If it's true, it does the statements inside and then goes on. If it's false, it doesn't do the statements inside and goes on. Okay, that's an if statement. This is a while statement. If it's a while statement and evaluates the expression and it's true, then it does the statements and it comes back up again and evaluates the expression again. If it's still true, it does the statements again, comes back around. It keeps on doing this until it finally evaluates to false. Then when it evaluates to false, it skips the statements and goes on. Okay? So it's the difference between a while and an if. They're very similar, except for it's kind of like the only way to get past it. The only way to get past an if statement, well, yeah, for a while loop, it kind of gets stuck in a loop until it ends up being false. Well, what that means is that something's got to make it so this is going to eventually evaluate to false. Because if the evaluation of this Boolean expression never changes it, and the evaluation of these statements never change what the Boolean expression evaluates to, then this thing is just going to keep on looping forever. And then you have to hit the stop button or something. That's a tight loop. So here's a simple example of a while loop that adds the numbers 1 through 4. So we set I equal to 1, sum equal to 0, and then it loops until it loops while I is less than 5, which means it loops while I is equal between 1 and 4. And each time it loops, it adds whatever I is to the sum, adds it to that thing, and then it increments it. And this thing is what's going to change the evaluation of the expression. See, so this makes it 2, loops around, makes it 3, loops around, makes it 4, loops around, makes it 5, and this is false, and then continues on. So here's a loop that calculates future value, which it's gonna be an assignment soon. And then do while, it's the same as while, except the test to terminate the loop is at the end instead of the beginning. And so what that means is these statements will always be executed at least once, and executes statements, and then it checks to see if this Boolean expression is true or false. If it's true, it goes back and does them again. And while this Boolean expression evaluates to true, it loops until finally the Boolean expression evaluates to false. And so here's the same. This is the same as this, except for this does the evaluation at the end. So there might be some things that are a little bit different, but anyway. And then a for loop, of course, is you have more expressions hanging around here at the top, but it loops for sort of more or less a set amount of time, although it doesn't necessarily be a set amount of time, because the Boolean expression, something inside the statements here can change this Boolean expression, just like in the while and the do. So anyway, this is a good place to stop. So 2:55. This class goes till 3. Yeah. All right. So this is good. We're halfway through. We're more than halfway through. And so why don't we come back, and I'll probably start back at this again, and we'll go through the rest of these loops, and we'll see where the breaks. Here we have this break where you're looping along, and someplace inside you figure out, oh, something's wrong, and you want to just break out, and this does it. Not all languages have that feature. Continue does not break out. It says, okay, we're done with this pass. Let's go back and do the next. Let's go back and check. So it's continue is it's a break, but it's not a break to break out of the whole loop. It's a break to break out of this pass and go back up at the top and possibly start the next pass. Go back up to the top, do this evaluation to see if you're going to do the next pass. All right, and this is breakpoints. This deserves a whole lecture on and so on. So, are there any questions? All right. So this was a good lecture today. I'll probably have your next assignment next Tuesday, but I want to see how you're doing so far. So, so thanks for watching.